All right, welcome back. Today we learned about the last little bit of rule that we're going to need for the rest of the semester. Actually, here, the chain rule. The chain rule. So chain rules is really important when we have a composite function. So this is an example of like sort of the structure of a composite function. It's where you can see like there's maybe some simpler function inside of a bigger function. So here in our examples below, you can see like here you've got this quadratic, but that's all being squared. So it's like a function inside of a function. Here we've got like, oh, that's just like my reciprocal function, 1 over something, but then that something is a different function itself. This could even be seen as like a function inside a function if you sort of think long enough. Or like here, we got something to the 9th power. So those are all examples of composite functions. So this is going to help us out with composite functions. So let's talk about what the rule actually is first. So the chain rule, if you're trying to take the derivative of f of g of x, then the derivative is first, the derivative of f with the original inside function still plugged in there. And that is going to be times the derivative of g, so the derivative of the inside function. Sometimes this notation is a bit weird to sort of think about. So something that I tend to do, I said this in the last video, is like I like to like sort of blob up stuff. So like for me, I view this as like, okay, so f of, oh boy.
Announcement, Destiny Armenta, if you're on campus, can you please come to the main office in Building A? Destiny Armenta, please come to the main office in Building A. Thank you.
So here we go, f of blob, f of a cloud, f of whatever. And then so for me, like I view the rule as like, okay, so I find the derivative of the outside, keeping the blob intact, and then I find the derivative of my blob for the outside there. So that's like how my brain sort of sees it. I figure out what's the inside function, and then I blob that up, and then I focus on the rest. So let's see some examples of where we would do this at. So for this one here, I'm going to look at this and go, cool, so like the blob, the inside function is this here. So if I'm thinking about the derivative of big F, so big F prime of x is equal to, all right, so I want to think about the derivative of the derivative of the outside function with the blob still intact. So like I might write something like f prime of blob times the derivative of the blob. Okay, so what does that mean here? Well, so I'm going to ignore this and just focus on the outside function. It's something squared. So I want to know, what is the derivative of something squared? Well, that's going to be 2 times the something. So let's write that down. 2 times the something. All right. And then that's going to be multiplied by the derivative of the inside. So now I turn my attention to what is the derivative of x squared plus 1? Well, that's just going to be 2x. All right. And so now we substitute it in. So the blob instead is 2 times x squared plus 1 times 2x. And you can leave it like that. You can also simplify it. What does it end up being here? Let's see, 4x cubed plus 4x. I think that's right. I hope so. But really, this might actually be more of a useful sort of tool. So what we'll find later here is that we're really interested in often when derivatives are equal to 0, which makes sense when you think about when we were sketching derivatives. We were always interested in when is it 0. Anyways, and so like if this is equal to 0, it's a bit easier to see what the solutions are than maybe this way. So, okay, so let's go ahead now and take a look at the next one. So the next one The first thing I'm going to do with this next one is I'm going to rewrite it so that way it looks more like the first example. And that way I don't have to, because I sort of implied like this is actually like an f of g of h of x. Like it's three functions being composed here written this way. But if I rewrite this as x squared plus x plus 1 to the negative third, now it's a lot like this one up here, and we should be able to just use the power rule to help us figure it out. So let me blob it up. So the blob is, again, this right inside here. So when I find the derivative of it, so this is little f of x, what I want to do is find the derivative of the inside function. So here, using the f prime would be confusing. So I'm just going to actually jump to this step here. So I'm going to cover this up here. Cover it up. There we go. So something to the negative third power. Something to the negative third power. Well, if I wanted to find the derivative of that, that's the power rule. Negative 3 comes down. Still got the something. And then that becomes to the negative fourth power, since we're going to reduce. Times, and now the derivative of the inside function there. All right, so then that gets me negative 3 times x squared plus x plus 1 to the negative fourth power times, and now the derivative of the blob inside is 2x plus 1. And there you have it. You could also rewrite this, because since that's a negative exponent, we could write it as negative 3 times 2x plus 1 all over x squared plus x plus 1 to the fourth. That also works. Okay. And so now for our last one here, this is going to involve more than just one rule, because what the inside function is a quotient. So when I find my blob prime, I'm going to have to think about the quotient rule. So that is something that's going to happen a lot here, is like I'm going to give you problems that require a lot of different rules, and we can't forget about them. So here we go. So the blob is this thing in here. All right, so let's go ahead and find the derivative. So g prime of t is equal to, so cover that up, something to the ninth power. The derivative of something to the ninth is going to be, we'll bring down the 9, the something to the 8th, reduce that power by 1, times, now the derivative of the inside, the blob. All right, so let's do it. So 9 times, bring back in the blob, to the 8th power, times, and now I need to find the derivative of this. So I use my quotient rule. So let me remind myself of that. So the quotient rule is first the derivative of the top times the bottom. And then we subtract that by the derivative of the bottom times the top. And that is all over the bottom squared. Okay, and so if we wanted to, we could simplify that a teeny bit. I'm not going to bother to expand anything here, just sort of make it look a little bit prettier. So here, and then what do we have? So it'll be 2t minus 2t, okay, 1 plus 4, so that's going to be 5 over 2t plus 1 quantity squared. I think I simplified that correctly. You could double check that. I should be showing more of my work. Bad, Mr. Schulten. Okay, so there you have it. So I think for me, the process that makes the most sense to figure this out is like stop to think about what is the inside function, and I like to cover it up and just go like, well, what is the derivative of something to the negative third, or something squared, or something to the 9th, or something to the 54th? And then I sort of do that, filling in the something with my blob, and then times the derivative of the blob. So that way I can sort of chunk it up. Like I find the derivative of the outside first, I'm not worried about this derivative, and then I think about that other derivative second. I think it makes my life a little bit easier. I don't have to try to juggle thinking about two derivatives at once. Okay, go ahead and take the survey after this, and I'll see you in class.